We need to find a way to spawn our player buffs in the game. I want them to be spawned randomly, but not as randomly as the asteroids. I'd like them to appear at a random position in a circle around the player. For this we would like to reuse our BP underscore asteroid spawner, but as you might remember, this spawner only spawns actors around these splines, and that's not exactly what we need because we would like to spawn around the circle, so we have to extend the spawner a bit. You're already familiar with inheritance and making components, but for this task we're gonna use another approach inside Unreal Engine, and this one we're gonna rely on reflection and different setup via exposing properties. So as you can see, this spawner has spawner mode, and here you can click and select radius, and now you will see this radius. And here I prepared some demonstration for you. You can click on this button and a random point will be drawn inside this circular area, and we're gonna use this position for our power buff visual representation. To achieve this, I've extended asteroid spawner a bit. First of all, I have added this enum class called eSpawner mode. It has spline and radius entries. Then I overrided this should tick viewports only function. We need this because we would like to see a debug preview even in editor. Then I have a variable for this enum. Then I have a debug toggle bdraw debug info, so we can disable visualization if you don't need it. Then this variable is actually using a new meta tag called edit condition because we only wanna see this variable if spawner mode is radius. Then I also use edit condition heights because we would like to completely remove it and not make it grayed out. Then I have min radius and max radius, and those variables are also using these edit conditions. Now let's take a look at CPP class. First of all, I've added this if mode inside tick function because we only wanna draw debug info if spawner mode is set to radius, and we enabled bdraw debug info. Then I have another if check. This time I'm checking world type, and if world type is editor, we would like to return because we don't really wanna spawn anything that in editor mode because we don't really have a gaming world, we have an editor world. And then I have this should tick viewports only. This returns the simple statement. It's practically the same as we did above. It also checks the world type, and if world type is editor, we can tick an editor. Then inside spawn function, I've changed how we get spawn location. For spline, I didn't really change anything, so the code is the same. The new code inside this radius. First of all, I've simply getting this random radius, then I'm getting a random angle, then I create a circle position, and this basically is cosine from random angle and sine from random angle. So because in trigonometry, when you have a point on a circle, x value is cosine and y value is sine. That's why I'm doing it here. Then I multiply it by random radius. We can do this because circle location is actually normalized, and we don't get any problems when we multiply it with another value. And finally, I'm setting spawn location to get actor location plus new vector that actually uses x and y coordinates from our random location. And that's it. Because we are using Kismet system library for drawing stuff, you need to add and include this one. When we spawn a player buff actor, we want to give it a setup, such as mesh color, buff type, etc. Only the data should be different, not the logic. A data asset was created specifically for such cases, so we are going to use one as well. Here I have a player buff definition that inherits from data asset, and inside it I have a T subclass of player buff, buff text, and buff mesh color. Let's create our first buff definition. For this, navigate to buffs folder and create another folder called definitions. Open this folder and here type data asset. In open pop-up, select our buff definition, this one, and call it DA underscore speed buff definition. Open this one and set buff class to BP buff speed, leave buff text empty for now and select the green color here. Yes, so now let's create a string table for this text. For this, navigate to Assets, String Tables, and create another string table. Call it stbuff. Key should be speedbuff, and text should be speed. Save and select this stbuff here and speed text. Now we have everything that we need. Now let's make a buff actor. For this, navigate to Blueprints, Actors, and here create pickups. Inside this folder, create a new blueprint class from actor and call it BP player buff. Open this one, and for this we're gonna use scene component as a root, then static mesh component, and let's make a mesh for this in modeling mode. For this, open modeling mode, click box and place it. And I guess we can make it half smaller. Yeah, something about this should be good for us. Now we can press accept, and maybe we need to center pivot because we would like it to be centered. Yeah, let's do it as well. Click Xform, edit pivot, and select center. Okay, now it should be fine. Now we can actually move it to meshes like we did previous times. Move here and rename it to SM underscore player buff. Okay, great. We can exit this modeling mode, open our BP player buff, and select SM player buff. Okay, good. Now we can also add text. Then we can rotate it a bit. Yeah, about this one. This text is gonna display our buff name. Before writing logic, let's briefly set up collision profile and make a material for this player buff. For this, click on static mesh, navigate to collisions and select overlap all as collision preset. Click compile and now open materials and create a material instance from turret material and call it my player buff. Set color to maybe red by default, and this one should be maybe 50. Yeah, I guess that should be good for buff. Press save, click on static mesh again and select this newly created material instance. Okay, that looks great. During playtesting, I actually realized that we did a bit too big mesh for player buff. Let's make a smaller one. Rename the original one to player buff old. Open modeling mode again. Click box and this time set width, depth and height to 25. Press accept. Open this mesh and move it to meshes folder. Actually, let's set original one. Now when we press delete on old one, you're gonna see this pop up. You can click force delete and rename this one to SM player buff. If you cannot do this, you should click meshes folder and click update redirector references and click delete unreferenced redirectors. Then you will be able to rename it to SM underscore player buff again. And now let's open blueprints, actors, pickups, our player buff, and set new SM player buff. And this one should be fine, but we actually forgot to center the pivot. Okay, let's do it now. Great, we can exit this mode, delete this one, and now pivot is centered. Nice, everything is fine now. Okay, let's briefly set player buff material. Okay, and now let's see the logic. For the blueprint logic, I've defined some variables. First of all, I have buff definitions. This is a buff definition array type with our DA speed buff definition. Then I have random definition. This one will be set here in begin play. Then I have a dynamic material variable, initial duration as float, current duration, initial is actually set to 8, and then I have is expired. Then I have a begin play node. Here I try to get a random definition from our array and set it to random definition. Then I check if it's a valid and do the rest of the code only if we have a valid random definition. Then I set current duration to initial duration and use sequence node. In first case, I simply create dynamic material based on our new MI player buff, then I set it to dynamic material variable. Then I check if it's a valid, and if it's a valid, I try to set color from random definition to its toward color parameter. Then I set this dynamic material to mesh. In second case, I set the text for our text component from random definition. Then I'm using a new node called scale animation. This is actually a timeline node. You can add this by typing add timeline. And this node should appear. Then you can double click on it and press this button and select add float track. Then you will be able to see a graph, and now you can use right mouse button to add a key to it. And now you can configure it. So I will just open mine. And as you can see, I have length set to 0.5 and first key has time 0 and value 0. This basically means that when time is 0, value will be also 0. And the second key I have at time 0.5 and it has one value. So it basically means that this value will be linearly increased depending on the current time. So you can hover mouse and you will be able to see preview value. Yes, then I connect update to set actor scale and use this scale as our new scale. So we can delete this one, and inside event tick I check if we're not expired, and only then I decrease the current duration, and then I check if current duration is less or equals 0. I set expire to true, and basically I have another timeline here, but in reverse order. So if we open it, my first key has value of 1 and second key has value as 0. So it's basically the same linear function, but in reverse order. And I similarly set actor scale based on this scale value. And on finish, I simply destroy this buff because we don't want to see any buff after it was expired. And finally, I have event take damage. For this, you have to press class settings and add our damageable interface to this. So inside this function, I check if we have a random definition, then I get player pawn and try to cast it to our player. Then I check if it's a valid class, and only then I'll try to get player buff component and add this buff class from random definition as a buff. Then I also destroy this actor. And that's all the code we need. And lastly, I would like to show you that I actually move this text component a bit. You can see my values here. Now let's try this in the game. For take damage function, we need to add a collision to our player buff mesh. For this, open this mesh, click on collision and add box simplified collision and press save. Now we can press play and we should be able to see our buff, and now we can see it, it was spawned, we can shoot at it and it will be picked up, and great, everything seems to be working fine. So as you can see, it was again spawned, and now if we don't shoot at it, it should destroy itself soon. Yeah, as you can see, it also works. Great. As a final step, I decrease max radius a bit, and also don't forget to check that you have BP player buff here specified as spawn class.